Hi, everybody. My name is Jason Meller. I'm the CEO and founder of Kolide, and this is Inoculating Rails Off against Bug Bounty Hunters, RailsConf 2020, Couch Edition. So a little bit about me before we get started. So I guess the first half of my life, I essentially was kind of like a little bit of a script kiddie. I've been sort of someone who's spent most of their life breaking things. And then around 2010, I discovered Rails. And as someone who started off their career as a cybersecurity professional, I found that my passion was basically building web apps for folks who really wanted to fight the bad guys. So my career has basically been built on top of user experience coupled with cybersecurity and trying to build good tools for defenders and people who really care about security issues. So as part of that, the thing that I like to do, I founded a company called Kolide. And essentially, Kolide is just it's a Rails app. It's a security app for devices. Instead of locking them down, which we think is a really bad idea, especially for folks who are engineers and they need to take full advantage of the device that they have, it actually looks for issues like security and policy issues and notifies you on Slack when it detects those issues. So instead of having things where you can't actually adjust your firewall or you can't actually change any of the settings of your laptop, we essentially have a little hand on your shoulder letting you know when you're in violation of major events that put your company at risk. These are things like unencrypted SSH keys that might be used to access production, or things like, you have a backup of the production database on your hard drive and it really needs to be removed. These are the types of things that we detect, and we try to do that instead of looking for things that are more like fear, uncertainty, and doubt, like advanced threat actors and things of that nature. So because Kolide's a Rails app, we had to make a lot of decisions about the different security practices that we wanted to have in our own application. So the first thing that came up, obviously, was authentication. It's a traditional SaaS B2B web app, and just like most of those, it needed to have the ability for someone to be able to simply log in with their username and password. So like everybody else, there's sort of this build versus buy analysis that we had to do. The key was, could we, kind of just put in a library like Devise, or did it make sense for us to really kind of build stuff from scratch? And most of the time, the answer is you really want to focus on the core parts of your application, not necessarily build, the extra features that need to be there for your app to work, but have probably been perfected by others. In our case, though, we had a little bit of a different, calculus when we made that decision. The first is that we're a security company, so it was really important to us that we totally own and were responsible for the authentication flow. And from that perspective, the key deciding factor there was that we really had to feel that we were in a position where we could make the changes necessary as best practices developed. So if there was a new way to really do authentication that made our app really 100 times more secure, we needed to be in a position where we understood the entire flow correctly. The second and most important thing was really, because we're a B2B SaaS app, we knew that ultimately we were going to have to build in every bell and whistle around Auth. Most B2B SaaS apps, they have to deal with password-based Auth. They have to do SSO, SAML-based SSO with things like Okta or OneLogin. They typically have OAuth, so they're allowing people with Office 360 accounts to log in, or with Slack accounts, or GitHub, or G Suite. These are things that we knew that we were going to need to add, including multi-factor authentication. So we wanted to make sure that we were building on a foundation that really made sense for us. I think the key here was that we didn't take the decision lightly, and we realized that Auth was going to be a lot of work. In fact, compared to the minimal viable product that we ended up producing as a startup, it was probably like 60 or 70% of the lines of code that we wrote in Ruby was to really handle the Auth process. And I think that's a realistic expectation when you're building a new app, is that you need to get Auth right. You can't really MVP Auth, especially for a business app. And so you're really signing up for a lot of responsibility that you have to be cognizant of. If you're not up for that responsibility, I think that's okay. And I think that's something that you just should be intentional about that decision. And if you're wondering, is Devise still a great solution for this? I think it's a pretty good solution out of the box today. And I think with some changes around password complexity, which we're going to talk about a little bit later, I think it can actually be a really great solution. So the crux of this talk is really about bug bounty programs. So what is a bug bounty program? Well, I want to start off with a little bit of a scenario that bug bounty programs were really designed to address, and kind of talk through the ways that you don't really want to deal with this issue. So let's imagine a scenario where a hacker has discovered a severe vulnerability in your application, and they're willing to disclose it, but only for a payment. Well, the common approach before bug bounty programs became popular was something to this effect.
The United States does not negotiate with terrorists. It's been our bedrock principle for 25 years.
We don't negotiate with terrorists. So what does that mean in practice? So a lot of folks, they really get defensive right away. When a hacker reaches out to them, they found something wrong with their application, they feel anger, they feel like they're being taken for a ride, they feel like they're being shaken down, and that kind of causes them to do some things that actually don't end up being in their best interest. They'll get their lawyer involved, which will give them a lot of expensive advice, maybe issue some, statements or sort of like, bad things to the attacker that really aren't going to be effective. They're going to threaten you may end up threatening the attacker if they end up disclosing any vulnerability that they found, yet you're not willing to pay for it, which is kind of weird. And you may even attempt to implement ineffectual technical controls. You may go to your engineers and say, listen, we need to block this guy's IP address, we need to delete all their accounts, and we just don't want them to be able to access the application again. So what are the outcomes if you end up going this route? Well, the outcomes end up being things like, well, you're not going to pay for the vulnerability, so let's just sell it to the highest bidder, which is an effective strategy for the hacker if your service is really popular. And if there's no bidders, well, maybe they can leverage that vulnerability to actually do things like exfiltrate, users from your database, or actually even get password dumps of hashes and things like that. But perhaps, maybe the hacker isn't a criminal. Well, at the very least, instead of doing things that are going to, further extort you, they're going to just post about it on their blog. They're probably proud of the things that they did, and they want to be able to, talk about it. And likely they're going to include the conversations that they had with you, including all the legal threats that you may have given them, things like that. Basically what I'm saying is 99% of in these scenarios, your company's going to be worse off. And your unwillingness to reward someone is really going to, basically end up costing you from a security perspective, reputational perspective, and it's just going to hurt your business overall. So let's just kind of talk a little bit about the perspective of the attacker, the hacker, the researcher, whatever you'd like to call them, and what kind of causes them to really want to do responsible disclosure. Well, if you think like someone, even in the past, I was sort of in this camp, was I really liked breaking things. I loved coming up with creative solution to work around apparent security that was in place. And I wanted to do that all day long. The problem is that, at least when I was doing it in the 90s and early 2000s, there was really no way to do that and also be on the right side of the law. I was constantly thinking about, am I in a position where I'm doing something that's going to eventually have the FBI knocking at my door, but I want to be able to do it constantly, so is there a way for me to earn money from this? Well, with responsible disclosure, kind of through a bug bounty program, you're helping the attackers essentially get to a point where they can enjoy what they do, they can actually have it be their full-time job, and then not have to kind of have a, looking over their shoulder where they're worried about like the FBI or the CIA getting involved with their activities. And so you're providing a legal and potentially profitable way for them to practice their craft. And it's a win for them, but it's also a win for you because you're getting what ends up being a highly discounted continuous penetration test for your application. So this is why this exists. It's not because it's charity or something that you want to do to kind of quell hackers. It's because there's value to your business in actually moving forward with a bug bounty program. So let's say I've convinced you and you want to move forward with a bug bounty program. You're signing up for like HackerOne at this exact moment. What are some of the pitfalls and how you may incorrectly implement this bug bounty program? Well, the biggest thing is that you may still be on the defensive when someone actually starts probing your application for vulnerabilities. Typically, researchers, hackers, they end up, kind of creating a lot of noise through exceptions in your application. You'll see them probing different controllers, passing invalid formats. These are going to be noisy and you're going to become aware of them. And it's at that moment that you have to make a critical decision. Is this person actually impacting the app in a way that other users are going to have a degraded experience? Or are they just creating like a lot of noise for my team to look through and generally it's okay? And if it's more the latter than the former, I implore you to let them finish their job because they may end up providing you with a really valuable bug report. Sure, you're going to have to pay for it, but you're going to learn something that you didn't know at the end of the day. If you stop that work early on, you're essentially negating all the benefit of the program. Ultimately, a lot of the other bullets here are related to kind of minimizing or finding a way of weaseling out of doing the reward for a valid bug bounty report, either through like kind of a bad faith argument around the impact of the report, so you can actually minimize the amount of money you want to pay out, paying out less than something like HackerOne is actually recommending through their program, or someone has repeated a bug that you got, but you didn't end up fixing it in a timely manner, but you're just going to say, we don't get any value of this because we already knew it existed. I think that's the wrong way to go. And the reason why is you want to incentivize those attackers to come back, and you want them to actually work through beyond like the basic vulnerabilities that they're finding. So even though they might be finding repeats at first, if you financially incentivize them above the normal payout amount, you're going to be in a position where they're actually going to be coming back to your app and actually running it through its paces, and you might find some new stuff as well. The biggest problem, though, that you can maybe find yourself in is you end up kind of over-legislating your bug bounty program, and you end up placing a lot of things out of scope. In fact, Valve was guilty of this exact thing last summer. So I'm going to use them as a little bit of a use case here and talk about the wrong way to approach this. So last summer, a major headline dropped about Valve through their Steam client, which the headline was, "Hacker drops Steam 0 day after being banned from Valve bug bounty program." This is huge, and it's definitely one of those things that you don't want to see as a company, a headline about you. So there's two critical things that caused this to happen. We're going to walk through the entire scenario. But for Valve's bug bounty program, they ended up getting a lot of reports around vulnerabilities that required one or two things. The first was attacks that required the ability to drop files in arbitrary locations on the user's file system. And the second one was attacks that required physical access to the user's device. And there was just so many of these reports that they were getting. They were like, we can't pay out for all these. We're not going to be able to fix all of them. So we're just going to not pay out, and they're just out of scope. So let's see how this played out in reality with this particular hacker. So the hacker ended up reporting a series of privilege escalation vulnerabilities about the Steam client, but they required either one or both of the out-of-scope vulnerabilities that we mentioned earlier. So Valve, to their credit, they responded right away, but they responded with the report being not applicable because it was out of scope for the program. So it shouldn't surprise you that, okay, well, the hacker's not going to be paid for this, so they're going to kind of revert back to what I was talking about earlier. They're going to immediately disclose the vulnerability. Finally, because he did that, Valve actually banned him from their bug bounty program, which was just ridiculous. Suddenly something wasn't worth paying out for, but because they were so angry he disclosed it publicly, they're actually banning it. Now, this is where the story takes a turn. The hacker continued to find more serious vulnerabilities in the Steam client that didn't necessarily require these out-of-scope vulnerabilities. But because they were banned from the bug bounty program and sort of persona non grata, they just immediately disclosed them as 0-day vulnerabilities because they couldn't report. And as a result, it was a PR nightmare for Valve. Users aren't safe, and it was a horrible outcome. The ultimate takeaway here is that there is a headline test that you should be applying to every vulnerability report that you get. If it's really, truly not a big deal, then it should pass this test. And the test is simply this. Before deciding not to pay, imagine the report becomes a headline in your favorite newspaper, Washington Post, New York Times, whatever. Are you still okay with that headline being there and not paying? Because if the answer is no, you should pay up for obvious reasons, because there's nothing stopping that person from simply publishing the results, a journalist finding it, and it becoming a headline. So we now live in a world full of bug bounty programs. Probably many of the organizations you work for already have one set up. Maybe they can be upgraded with some of the advice that I just gave, but ultimately they're there. So now hackers are they're faced with the economics of actually being in business as a bug bounty hunter. And when I say bug bounty hunter, I'm talking about someone who's really doing this in an automated fashion, and they're enumerating as many organizations as possible so that they can actually reap the maximum amount of financial gain that they can. So their process is very simple: enumerate companies, use automated tools to find kind of low-hanging fruit, continue to manually inspect those companies for more things, pull everything together in like an automated report with pre-generated snippets, and then submit, wait, and then profit. So there really is an art, though, to finding these vulnerabilities, because if you think about them on a spectrum, you have sort of low payout vulnerabilities that are valid, but they're not damaging, and then you have high payout vulnerabilities where there's this massive impact to the business. They want to be on that right side. And then on the other side of the spectrum, you have manual discovery, the amount of actual effort, hours of singular effort that hacker has to put in, versus can I just use automated tools to find them? So, obviously where we're going with this is that they want to be in that upper right quadrant. That's where all the high payout, cheap action is. Now, that really consists of things like that are in the OWASP top 10. SQL injection, basic cross-site scripting, just straight up broken authentication, session replay attacks. We're not going to get into the nitty gritty of these. I definitely implore you to look into what they are if you're not familiar with them, but you may not be, because Rails really does a great job of mitigating these at a basic level. Of course, it's still up to you to make sure that you're not working around those mitigations, but for the most part, Rails is there. And for the most part, most mature applications have a lot of these solved anyway. So it really behooves, someone who's trying to be an economic hacker to not really focus on these, because that low-hanging fruit has already been picked. So what can they do in relation to, still getting the highest payout for the least amount of effort? Well, the goal is in what we sort of call vulnerability chaining. So what they're going to start doing is they're going to start trying to find lower payout things that they can still automatically discover. But once they do, can they actually do things where they're actually chaining them together with maybe lower or even higher payout manual vulnerabilities to actually have a multiplier effect to improve their outcome? So the goal here is can we actually take all these things together and combine them together in a giant chaining vulnerability and generate something that's just completely unspeakable evil that a company's going to pay out big bucks for? So in my world, we call that chaining vulnerabilities. Essentially, what can hunters do to try and turn seemingly innocuous low payout vulnerabilities into major payout monsters? So chaining vulnerabilities, here's a real report that we received. This is very early on in Kolide's life. This is for an app that we no longer have anymore. But just like I talked about in the abstract, I really wanted to share real reports so that you guys get a sense of the types of things that we actually see in the wild. So this is, again, we use HackerOne for our bug bounty program. We ended up paying $1,350 for this. And for us at the time, we were a fledgling startup. We didn't have a nickel, in our bank account. This was a really big deal for us to be able to pay this out. But you'll see why in a second. So there's 5 chain vulnerabilities that made this end up working out. And I'll talk about the outcome of how these chain vulnerabilities there, but you'll see that there's a lot of innocuous stuff here. First, there was a stored, cross-site scripting attack, which is never good. The second was, even though we had a content security policy to kind of mitigate some of the risk around a cross-site scripting attack, they were able to bypass that. We had several low-value cookies in our app. The session cookie was protected, but we had some kind of trivial cookies, like holding the email for the Remember Me form for pre-populating email address and the Auth and things like that. And then we kind of had this ability for someone to write any value that they wanted. So when they were logging in this sort of 2-phase login setup where you put in your email address and then we redirect you to the right login flow, they just could put in whatever they want. We would remember that email address for next time, but they realized it could be anything. It didn't have to be an email address. And then based on that, there was sort of this idea around a theoretical open redirect. Now, all of these vulnerabilities by themselves, we're talking about $100, maybe $150 for some of them. The theoretical attack is obviously useless unless you're chaining it together. So we're in a position where, individually we're talking little peanut stuff, maybe not the cross-site scripting, but, with the CSP bypass it becomes more valuable. So the value grows as you kind of move down the chain. But ultimately what they were able to do is they were actually able to redirect users after login by actually forcing a cookie onto their device that would actually cause them to be redirected to a spoof page off-site to actually collect their credentials. So using this chain of vulnerabilities, they were able to do something kind of unspeakably evil. And if we had this type of vulnerability in our app today, now that we have hundreds of customers and we're doing well financially, we would have paid out probably 10, 15, maybe even 20x this amount, because of the proportionate impact that this had. So it was fortunate that we had a bug bounty program early to kind of catch this, but it goes to show you how these chain vulnerabilities can really add up. So what is your goal? You want to inoculate your app against easy to find but obscure bugs, especially in the authentication region, because most apps have auth. So they're going to focus their automated attacks there. And that will allow you to prevent something like a $500 bug from becoming a $10,000 bug. So really quickly, what we're going to do is we're going to talk about another real bug bounty report that Kolide received. This one we only paid $250 for because we didn't have that chaining that I'm talking about. But let's go into it. The basic premise of this attack was that right off the bat, they're coming in with an assumption that the attacker already has access to a user's account. So they've already established that. It's a big assumption, but we'll go into it. The second assumption that we can make is that because they have access to the account, they have a valid session cookie that they can replay to us at any time. We'll take that session cookie, and it's essentially like a password, right? They could just log in. Essentially, from there, they discovered that if a victim knew that they were there and they're like, I got to reset my password to lock this person out, it wouldn't matter. Even though the password was reset, their session remained valid, and they could continue to use that person's account no matter how they changed their auth. So ultimately, the problem here is that the attacker retains access indefinitely by replaying that singular existing valid session over and over again. So why was this a big problem in our Rails app if, I've been doing this for 10 years and, we've been doing it, and how was this able to slip by? Well, I think this is one of those cases where Rails just happens to be especially vulnerable. And the big reason why is by default, Rails' session store uses cookies. And cookies just don't lend themselves to server-initiated revocation. So if I'm a server and I want to get that cookie off someone's computer and I want to make sure that it's invalid, it's kind of not obvious in how I would maybe want to do that. And the other issue is that using something like has secure password, it isn't as bad or as included as something like devices, where this is sort of thought through on the password reset flow. So this is a perfect example of, we rolled our own auth very early on in the history of the company, and we ended up doing something worse than what was available on the market. So this is one of the downsides of actually rolling your own authentication. So let's analyze the vulnerability chain here really quickly. So we first have the actual reported vulnerability. And that's really, there's two segments to that. There's lack of session revocation. There's no mechanism at all for it. And the second is, even if there was a mechanism, which there isn't, we're not actually utilizing it to actually protect any high-risk actions. So this is the main thing that we want to focus on. But the things that are really important to think about is that assumption earlier, the attacker already has access to the user's account. Well, why? Well, is it because we have a poor password quality issue? Is there valid account enumeration where they're able to guess, a valid account and then use that, poor password quality to gain access that way? Or maybe there was just a lack of multi-factor auth, which would have stopped them even if they knew the password. Or maybe they didn't even know the password at all, which was likely, and they were just able to get access to the session cookie, via Crosssite scripting. So this is a perfect example of how this baked-in assumption, which may kind of force you to get defensive and say, oh, I don't want to pay out for this vulnerability because the premise is so ridiculous. They already have access. Well, if you actually think through that, you may actually learn a little bit about, thinking through those scenarios. You might be in a position where you can improve the security of your app. And it's these types of things where this will multiply the payout. If they can actually show this part where they don't have to start off with the assumption of, I'm already in, then it becomes a much more serious manner. It's much easier to say, if this was a headline, this sounds like a really bad vulnerability. But what's even worse is after the vulnerability, is what is the impact of that vulnerability in real terms? Are they able to go in and lock the user out permanently? Can they destroy sensitive information? Can they exfiltrate sensitive information? If you don't have mitigations in place to kind of limit the impact of these vulnerabilities, you again are going to pay out massive dollars. So what we're going to do is we're going to take a short break, and then we're going to actually dive into each one of these little segments here, and we're going to talk a little bit about how we can solve them one at a time. So we'll be right back. All right, welcome back. So when we left off, we were going to talk a little bit about how we wanted to actually dive into each one of these pieces of the vulnerability chain and learn about how we can inoculate our auth to actually mitigate those vulnerabilities. So let's dive in. So let's talk about session revocation. So the goal here is we want to invalidate all sessions when a user resets their password. And the first thing that I would normally reach for before I learned about a different method was really just, let's do this on the server. If the cookie is really the source of truth it's hard for me to kind of reason about how we can just take that cookie off someone's computer. It's client-side controlled. They're going to be able to prevent me from expiring it, if I send it a command. So let's just store the source of truth on the server and just have the cookie be like a reference to that row in the database. And then all we have to do is just delete that row in the database when we want to invalidate all the sessions, which is great. It works. And in fact, there's a gem to do this. It actually used to be built into Rails itself. It got spun out as a gem. And you can just kind of change the implementation of the session store to use active record, for instance, or you could have one for Redis. And essentially, you have now the source of truth on the server. You knock out that row, everybody's invalidated. Now, the problem with this is that you've now added a new database lookup per request. So if you're in a high performance situation, that might be something that you don't want to do. But the biggest issue is that Rails just thinks sessions are really cheap and free because they're cookie based by default. So it's making sessions all over the place when you don't want it to. Like maybe you have your marketing site in there. It's going to create sessions when you're there and you're unauthenticated. You're on the login screen. You just signed out. Now you have a new session. And so because you're creating all these sessions and then you have old expired sessions, you need to kind of reason about how you're going to clean up this table on a regular basis. With Redis, you can use expiration keys and things like that. But with the database, you may have some real, cron-like jobs that you have to run on a regular basis to make sure that table doesn't fill up and doesn't cause like a major catastrophe later on when, the database like exceeds the max amount of rows allowed for your, let's say you're like your Heroku plan or something like that. So I think that, server-side sessions are definitely a valid approach, but I think there's a lot easier way to do this on the client side. And it really talks about how you can actually change up, the standard practice for how you actually set the session in the first place. So most sign-in actions, they look like this. You have a post for like a sessions controller you create, and you just look up that user's email, you pass, make sure that the password is there and it's correct. And then you just essentially, set the session hash with the user ID of the person you just authenticated. And then when you look this up in subsequent requests, you just make sure that user exists and then they're logged in. Now, this approach works. This is how most people do it. But the problem is that this valid session is this immutable ID. You're not going to change the user's ID because of all the foreign key associations with it. And so it's never going to change, and therefore you've kind of crafted this perfectly valid, permanently valid cookie that anyone can use to log in as this user in the future. And that's what we want to avoid. Is we need to be able to actually revoke these on a case-by-case basis. So to actually do that, it's a really quick fix. All you have to do is generate a separate, temporary token, and then set that along with the user ID like you would normally set. So you can set the token, on create, and just using something like secure random hex, and you generate a random hexadecimal number, and you store that along with the session. And then when you go to validate it later, you're not only checking if that user ID exists, but you're also checking if that session token matches what's currently in the user. Then when you want to reset all other sessions, let's say someone's resetting their password, all you have to do is just update that user's attributes where you're rolling that token to a new thing, and then you're in a position where you just simply change their current session with the new token, and then the result will be everybody's logged out except the user who's actually resetting their passwords. Again, pros here is minimal code. You're not doing an extra database lookup. You have to look up the user table anyway, and it's a safe technique. Divides is actually, this is how they accomplish it without using server-side sessions. Now, the only con here is that you have to target everybody at once. You can't just pick and choose specific sessions if you want to. So now that we have that middle problem sort of resolved, let's now talk about where the real money is. It's let's talk about how did the attacker already have access to the user's account? In our case, we were all set on all these things, but this is the type of thing that I wanted to talk about because it's really required from an inoculation perspective to make sure that you're resistant to these multiplication payouts. So the biggest one is, this could be a whole presentation itself, is poor password quality. And it's really hard to get this right because it changes so much. And Basecamp is a perfect example. They had an incident last year where people were able to get into other folks' Basecamp accounts essentially because they had reused passwords from other services like LinkedIn and Facebook and things like that where those passwords had leaked in the past. So it's important that you get this right. And I think it's important to also state that you shouldn't be scared of using passwords because this is tough. Because if you just shy away from passwords and you require stuff like OAuth or single sign-on, you're kind of causing your users to have to engage with some of these other companies like Google, who may not have their privacy interests at heart in order for them to just simply use your application. So I think having password-based auth is, I think, a noble cause, and I think it's important. But it's important that if you do decide to do it, that you're going to actually, manage those risks. So I would say the new minimum requirements for passwords, like throw away everything you knew. The first thing is a sophisticated password complexity checking capability. And you want to make sure that you're doing things that aren't old school, like, I want to look for, make sure they have this amount of symbols, or the length has to be above this but below this, or the password has to expire arbitrarily every 3 months. Those are all things that actually had no real basis in real research that proved that they actually prevent brute force attacks or improve the security of passwords. You're going to want, a real tool that's actually bumping up that password against locale specific dictionaries. The other thing is you want to be able to continuously check these passwords every time that the user signs in, and when they first create them, to make sure that they weren't disclosed in prior breaches. I'll talk about how to do that in a second. And as I mentioned earlier, you want to rethink those prior accepted practices. So here are the tools that you can use to get this done. We've used ZXC VBN, which is a mouthful, but it's from Dropbox, and it's this great client-side JavaScript utility that allows you to build screens like this, where you're generating like a really well-reasoned-through score from a passwording perspective, and then you can actually give them really great user experience around why that password may not be good. In this case, this is a commonly used password, so it's taking advantage of a dictionary in the back end. It's all client-side, it's really fast, and it's really small. I highly recommend you check it out. And then, of course, with something like exec.js, you can run this in the back end and enforce a certain score so that you can just write a Rails validation for it if you want. The second tool that I highly recommend is Pwned. This is a gem, and it uses the Have I Been Pwned service, which if you've ever used, you just go there and you put in your email address, and it'll actually tell you all the services that may have leaked your password in the past. You have a way of this actually allows you to interact with that programmatically by sending anonymized chunks of the password, not the full password, just little chunks of it to validate whether or not that password may have been a part of a breach or not. And you can create a screen like this. I highly recommend that you not only check out the gem, but all the white papers associated with that anonymity model, because it's really cool, and I think it's one of those things where you can get a lot of value. And if you're a little scared about the API, there's ways that you can actually bring in all that information locally to do those comparisons. Ultimately, the other thing that I want to talk about is valid account enumeration. I'm not going to spend a lot of time on this, but ultimately, this is sort of up to you. A lot of folks decide just to accept the risk. But what is this at the end of the day? It's, I'm resetting the password and there's an error message that tells me I haven't signed up yet. That's the type of thing an attacker can use to validate that an arbitrary email might already have an account there. What I've seen a lot of folks do is they say, on the password screen or the login screen, we're not going to disclose whether an account exists. But for the password reset screen, we are, because of the support burden. I think this is one of those things where you just have to do it or not do it. You can't kind of do it halfway. And you really need to signal to the researcher that you either are all upfront about doing this, or you've decided that we're going to just maximize on the UX and lower the support burden and let any unauthenticated user know if they have an account or not based on them inputting an email address. The reason why you have to kind of think this way is that the effort to get this done is actually quite high for password-based authentication. With OAuth, you don't necessarily have to spend a lot of time on it because you've already validated that they own the email address, so delivering error messages to them in that vein is fine. But if someone's just putting in an email address in a forgot password form, you have to really think carefully. So I put together a checklist here around the places that we really had to think about this. So I mentioned password reset. New signups is another common one. One that's often forgotten, though, is inviting users via email onto your team from within the application, especially in like a single tenant setting where a user can only belong to one team or organization. You don't want that place to be the place where you can reveal maybe to an unrelated team or org that another email address exists. So just take a look at the slide later and kind of look through how we message these things. and recognize that there's a lot of nuance here and there's a lot of email that you have to write to kind of cover all these different scenarios. Finally, in this section, I want to talk about multi-factor auth. Again, if you're not using password auth and you're just relying on the multi-factor auth of some of the SSO services or OAuth services that you're using, that's fine. But if you are doing password auth, I highly recommend doing multi-factor auth. It's almost unacceptable at this point because of the security implications of, sure, you're letting them log in with a password, but you're not giving them the right tools to really protect their account. So the key thing here is that unlike passwords, where there is change, but we've mostly dialed in the best practices, best practices here are changing all the time. Good example of that is SMS-based multi-factor authentication methods are no longer acceptable. So even as a backup, and the real goal here is you want to switch over to soft tokens that are time-based, or things like WebAuthn, which allow you to log in with something like a YubiKey or like the Touch ID sensor on your device, something with a secure enclave. So the goal here is that you want to be on top of those best practices. You want to have ways of ensuring people get locked out of there with generating backup codes, but you also want to ensure that they're putting them in password managers. I mean, Kolide, one of the checks that we have on devices is just looking for these things that exist in the download folder in plain text. Their Heroku two-factor codes, their G Suite two-factor codes, their GitHub two-factor codes. Everybody puts them in their downloads folder and they forget about them. They need to be in something like 1Password, or at worst, something like their keychain. So the other important thing to remember here is you want to have a policy for what to do about totally locked out users who didn't download their codes. They have no secondary method of getting in, and they're just locked out. You want to come up with that policy before it happens so that you're not kind of applying this case-by-case bias. Oh, well, we know this guy, and it sounds like it sounds like the email is fine that he's emailing us from. No, you have to come up with a policy beforehand and make sure that you follow it to the letter before you endeavor to build a multi-factor authentication solution. On the Useful Gems resources section of the slide, check out what Basecamp did in terms of how they set up their two-factor auth. They have a lot of great resources there, and I think they did an excellent job writing it up from a feature perspective and how they built it perspective. Last one in this section is cross-site scripting. I'm not going to spend a ton of time explaining what cross-site scripting is, but just think of it as an attacker can just leverage unsafe evaluation of JS to run any arbitrary client-side code in the victim's browser, which is really bad. And the key thing to remember here is that this is usually the missing ingredient that an attacker needs to complete a high-impact vulnerability chain. So there's two ways to avoid this. The first is, make sure you really think about every usage of HTML safe, and that you're using, on the client side, a lot of things that know how to escape HTML, basic templating systems. React does that by default, but you want to make sure that you're not doing crazy stuff like concatenating strings together and just putting user input in there. If your diligence around this fails, your last line of defense is really content security policy, and this is built into Rails 6, and it's available via the secure headers gem if you're before Rails 6. And the goal here is to create a browser-based policy that will block any arbitrary execution of JavaScript based on rules that you define. And I say that this is the last rung of defense because if you don't do this, if you don't think about it that way, you'll end up becoming lax around your diligence around cross-site scripting in general because you think that you have this protective effect. But it's really the last barrier before the attacker gets to win. So we talked about this earlier, in our kind of example scenario, they did bypass the CSP. Well, why? In our case, we had a CSP set up through secure headers, but the default, when you don't specify a full configuration, is to allow any SSL-served JavaScript to execute without restriction. And that's a big problem because all it takes for an attacker to really bypass the CSP is to just simply register a domain and get a valid SSL certificate. So you need to make sure that when you build your CSP, you're taking all that to an account, and you're taking an approach of block everything first, and then only allow domains and scripts that are, known to you. Preferably don't use even domains, use nonces and hashes to verify the script's contents, and then run your CSP through a third-party evaluator like the one that I have linked here, which will show you all the different potential attack vectors that might still be possible with the CSP that you've decided. This is going to cause a lot of pain if you have a mature application. You're going to have to go in, you're going to have to look at all of your usage of JavaScript and likely change a lot of stuff, but it's worth it at the end. This will really save your tail. All right, last piece is how do we mitigate the impact? Well, audit logging is a no-brainer because if I was a victim of someone taking over my account, I want to be able to know exactly what they did and enumerate the damage that they're there. There's a lot of great gems for this. We're not going to go into it. The thing that I want to focus on is password reprompting. So password reprompting is, we have it on the right here, is you have essentially a protected action like changing your email address, and instead of just letting them do that, you reprompt them for their credentials to make sure that it's really them. This is really effective if the attacker only has like a session cookie. They don't actually know the true credentials, and you can actually stop them from doing a lot of damage. The key here is two things. One is you want to make sure that you enumerate all the high-risk actions that you really want to wrap this around. And I've done so in the slide below. There's likely more that you'll need to consider. Things to watch out for are anything related to them being able to escalate privileges of other users, invite new users in, create other API credentials, things that allow them to maintain persistence on that organization's account. The second thing is more of a user experience thing, is you want to really avoid constantly reprompting them when it seems unnecessary. Good example of this is I've just signed in and then I'm going in to rechange my email and then it reprompts me even though I just put in my password. This is where something like a sudo mode, where you're sort of simulating like the time-based, allow everybody through to perform privilege actions because they just signed in type of experience. GitHub has this, and I'm going to walk you through how we got this done in Kolide. So it's actually really easy. What we're looking at right now is an active controller concern or active support concern that we mix into a controller. And then all we have to do is just call this before action require verification, which we enumerate kind of what we're doing there. First thing we check for is, are they in that sudo window? And the way that we do that is through a protected cookie where we're sort of signing a timestamp. And if the timestamp exceeds 1 hour, we say that, that's invalid and they now need to go through the verification process. And if it is valid, then we just let them skip through and perform the action uninterrupted. But if they have to perform this verification process, the key thing to know is this section right here. You're going to want to save everything that they were doing. What path were they trying to access? What was the request method that they were coming in with? Was it a get? Was it a post? Was it a patch? And if it was one of those things, what were the parameters that they were utilizing in that request? The key reason you want to do this is you want to simulate all that later after they've done their authentication process. And the way that we do that is you take all this information from the session and we generate a hidden form. We automatically submit that, or if they have JavaScript disabled, we just have them click a button. And then that submits exactly what they were intending to do in the first place, and they get redirected to the page that they expect. So again, the goal here is to utilize this information. You want to create a hidden form after they've signed in, and then you can send them right back to where they were going through with a minimal impact on the experience. So we're almost out of time, so let's wrap up. I think there's 3 takeaways I'd like you to take away from this presentation. The first is decide whether or not you're up for the challenge of rolling your own auth. I think that, at least for us as a security company, it was a no-brainer, but for your application, whether it's B2B or B2C, it really kind of comes down to the things that you want to prioritize in your business. If you are ready to roll your own auth, I think you have to be ready to treat it like as well as the rest of your product. If you don't have a bug bounty program, you should be creating one. You should, looking at all the recommendations we made and how to not make massive errors and how you treat the hackers and the researchers that are submitting reports there. And then understand that every time that you pay for one of those reports, you should be celebrating because you're actually saving a lot of pain and anguish, in terms of getting that information out of the way, either through a nefarious actor who isn't responsibly disclosing or through a very, very expensive, pen test that you have to do on a more frequent basis because you're not getting these regular bug bounty reports through your program. Finally, if you decide to do a bug bounty program, which you should, you need to inoculate the auth of your app so you don't have to pay out large dollars for chain together vulnerabilities using the techniques that we described. There's one resource I want to leave you with. It's this Rails security guide. So this guide has been around forever. I still think it's in really good shape and it's worth a read through. It covers a lot of the topics that we mentioned today, and combined with some of the topics that we talked about earlier, I think you'll be ready to really level up the Rails application that you have, whether it's Auth or other parts of the app. And with that, I thank you for your time. Feel free to contact me with any questions or comments at any of these places listed on this slide. Thank you and have a good day.